Japanese were shocked when American pilots shot down Admiral Yamamoto. April 14, 1943. Rabaul, New Britain. Vice Admiral Madame Yugaki set down the intelligence summary and lit a cigarette, his face showing the faint contempt of a man who had watched enemies crumble before superior tactics. "Look at this," Yugaki said, sliding the document across the table to his adjutant. "The Americans believe they can match our veteran pilots with factory workers who learned to fly 6 months ago." Commander Yasumi Doi nodded, examining aerial combat statistics from recent engagements. "Their industrial capacity means nothing when their pilots lack bushido. What good are 10 aircraft when 9 pilots lack the spirit to press the attack?" Captain Watanabe Yasuji, intelligence liaison from Combined Fleet Headquarters, frowned slightly at the assessment. "The Americans have increased fighter production by 400%. Their P-38 deployments in the Solomons suggest," but Yugaki waved him off dismissively. "Numbers without skill are merely targets. At the Battle of the Coral Sea, our pilots achieved 3-to-1 kill ratios. At the Eastern Solomons, 4-to-1. At Santa Cruz, our aircrews sank the Hornet and damaged the Enterprise with half the aircraft the Americans deployed." The mathematics were undeniable. Japanese naval aviation represented the finest fighting force in the Pacific theater. What Yugaki didn't know, what none of them could have known as they reviewed intelligence reports in that concrete command bunker, was that American codebreakers had already decrypted Admiral Yamamoto's travel itinerary, and that 18 P-38 Lightning fighters would intercept his transport within 4 days. The numbers would become devastating. 18 attackers versus 6 escorts, engagement duration 4 minutes, 2 Japanese bombers destroyed, Admiral Isoroku Yamamoto dead. The confidence in that bunker would become history's most expensive miscalculation, measured in the loss of Japan's most brilliant naval strategist, and the psychological blow that would reverberate through the Imperial Japanese Navy for the remainder of the war. The mathematics seemed irrefutable in early 1943. Japanese naval aviators had dominated the Pacific since Pearl Harbor, achieving kill ratios that seemed to confirm their superiority. At Pearl Harbor, 353 Japanese aircraft had destroyed or damaged 21 American ships, killed 2,403 Americans, and returned with losses of only 29 aircraft. At the Battle of the Coral Sea in May 1942, Japanese pilots sank the carrier Lexington and damaged the Yorktown, achieving favorable exchange ratios despite tactical setbacks. At the Battle of Midway, though Japan lost 4 carriers, individual Japanese pilots continued to demonstrate exceptional skill, with veteran aircrews pressing attacks despite overwhelming opposition. The Mitsubishi A-6M0 fighter represented technological achievement that seemed to validate Japanese confidence. Maximum speed, 533 kilometers per hour. Range, 3,000 kilometers. Service ceiling, 10,000 meters. Rate of climb, 15.7 meters per second. Armament, 2 20mm cannon, 2 7.7 machine guns. In the hands of veteran pilots with 800 or more flight hours, the Zero could outmaneuver any American fighter in 1941 and early 1942. The aircraft's range allowed strikes that American commanders thought impossible. Its maneuverability made it lethal in dogfights. Recent American failures seemed to confirm Japanese assessments. At the Battle of Savo Island in August 1942, Japanese surface forces sank 4 Allied heavy cruisers in 32 minutes of combat. American radar, American numerical superiority, American industrial might, none of it mattered when Japanese night fighting tactics and superior training delivered crushing tactical victories. The Americans lost 1,077 dead. Japanese losses, 58 dead. The mathematics were brutal and undeniable. Vice Admiral Yugaki's combat record justified his confidence. He had served as Chief of Staff to Admiral Yamamoto since 1941, participating in the planning of Pearl Harbor, the Indian Ocean Raid, and the Midway operation. He had observed Japanese naval aviation at its peak, watched veteran pilots achieve impossible results through skill and determination. He had seen American pilots, many with fewer than 200 flight hours, panic under fire, break formation, flee from combat. The Americans had numbers, certainly, but numbers meant nothing without the warrior spirit. Captain Watanabe brought his concerns to fleet headquarters repeatedly throughout early 1943. American fighter production has increased from 2,400 units in 1941 to an estimated 38,000 units projected for 1943, he reported in one briefing. Intelligence indicates they are training pilots in accelerated programs, graduating classes every 8 weeks. More concerning, their tactics are evolving. The P-38 Lightning possesses speed and altitude advantages that negate the Zero's maneuverability in certain situations. His warnings were noted and dismissed. "Let them produce 100,000 aircraft," one staff officer responded. "Each will require a pilot, and you cannot mass-produce the intangible qualities that make aerial combat effective. Spirit cannot be manufactured in factories." Lieutenant Commander Kenji Yanagiya flew as wingman in Yamamoto's escort on dozens of inspection tours. He had personally shot down 7 American aircraft, watched American fighter formations dissolve under determined attack, observed American bombers jettison their payloads and flee when pressed. "The Americans have courage individually," he noted in his diary, "but they lack cohesion. Their formations fall apart. Their pilots look for escape routes rather than pressing attacks. Our training superiority shows in every engagement." The mathematics seemed irrefutable. Willow Run, Michigan. March 1943. Henry Ford ran his hand along the B-24 Liberator bomber's aluminum skin as the assembly line moved the aircraft another 9 feet toward completion. This single facility produced 650 bombers monthly. Every 63 minutes, another B-24 rolled off the line, completed, fueled, armed, and ready for combat deployment. Production progression told a story that Japanese intelligence either couldn't believe or couldn't process. In January 1941, America produced just 1,200 military aircraft monthly. By January 1942, production reached 4,000 monthly. By December 1942, American factories were producing 6,500 aircraft monthly. By March 1943, Willow Run alone was producing more bombers every 24 hours than Japan's entire aircraft industry produced in the same period. This single facility was producing more 4-engine heavy bombers than the entire Japanese empire possessed in its entire military inventory. Rose Will Monroe, previously a waitress from Pulaski County, Kentucky, now operated a riveting gun on the bomber assembly line, fastening 3,840 rivets per shift on wing sections. Each rivet had to meet precise specifications: exact depth, exact pressure, exact spacing. She installed more rivets in an 8-hour shift than an entire Japanese aircraft factory used in constructing 2 complete fighters. Her team completed 7 wing sections daily. A single wing section contained 4,200 rivets. Her workstation alone processed 29,400 rivets daily. The Japanese aircraft industry's entire daily rivet consumption across all manufacturers totaled approximately 45,000 rivets. Will Monroe's single assembly line section represented 65% of Japan's entire rivet installation capacity. James Edwards from Memphis, Tennessee, operated the hydraulic press that formed aluminum sections for tail assemblies. His single station produced 36 tail assembly components daily. Each component required 47 separate pressing operations. His output, 1,692 precision aluminum pressings every 24 hours. The entire Japanese aircraft industry operated 23 comparable hydraulic presses across all manufacturers. Edwards' single press produced what would require 4 Japanese factories working simultaneous shifts to match. His machine never stopped. 3 shifts, 24-hour operation, continuous production. His single station's daily output exceeded the combined output of Nakajima's Oda plant, Mitsubishi's Nagoya facility, and Kawasaki's Akashi factory. Charles E. Sorensen, $1-a-year man from Ford Motor Company, managed production logistics that seemed impossible to Japanese industrial planners. He coordinated 42,331 machine tools, 1,600 separate manufacturing processes, and 7,500 different aluminum components. The facility consumed 4,200 tons of aluminum weekly, more aluminum than Japan imported in an entire month. Sorensen's supply chain delivered 11 million individual parts weekly to Willow Run. A single day's parts inventory exceeded what Japanese logistics officers allocated for monthly production across their entire aircraft industry. Americans discarded 14 tons of aluminum scrap daily at Willow Run. The scrap bent panels, incorrect pressings, damaged components, production waste went directly to remelting. Japan allocated 220 tons of aluminum monthly for its entire aircraft industry. Willow Run's daily waste exceeded 6% of Japan's entire monthly allocation. The mathematics were staggering. What Americans threw away as unusable, Japanese engineers would have carefully straightened, reformed, and reinstalled. The waste from Willow Run's single-shift cafeteria exceeded Japanese military rations. The cafeteria discarded 1,400 pounds of food waste daily: spoiled vegetables, overcooked meat, stale bread, kitchen scraps. Japanese infantry divisions in the Solomon Islands received 1,100 pounds of food supplies daily to feed 800 men. American workers threw away more food from one factory cafeteria than fed an entire Japanese combat division in active operations. Workers threw away defective tools that Japanese craftsmen rationed by the piece. A worn drill bit still functional, but below specification, went into scrap bins. Japan allocated 3 replacement drill bits monthly per manufacturing facility. Willow Run discarded 47 drill bits daily for not meeting exact specifications. American workers threw away in 90 minutes what Japanese machinists received as quarterly allocations. The aluminum shavings from machining operations accumulated in collection bins, 840 pounds daily. Japanese factories collected every shaving, remelted every scrap, recycled every fragment. At Willow Run, collection bins filled were emptied, returned to remelting facilities, and the cycle continued without thought. The daily machining waste from this single facility exceeded the total aluminum recycling capacity of Japan's home islands. Used cutting oil from machine shops, 320 gallons daily, filtered once, discarded when contamination reached 4%. Japanese facilities filtered cutting oil 14 times, used it until contamination reached 35%, then processed it for other industrial uses. Willow Run disposed of more usable cutting oil daily than Japan allocated monthly to its 3 largest aircraft plants combined. The single facility's discarded oil could have built Japan's entire month's production of Zero fighters. Captain Watanabe studied translated American industrial reports with growing alarm. Ford's Willow Run facility produces more bombers in 1 day than our entire industry produces aircraft of all types in 3 days, he reported in April 1943. More concerning, this represents one facility. American aircraft production includes dozens of such plants. Republic Aviation in Farmingdale, Douglas in Long Beach, Boeing in Seattle, North American in Kansas City. Each facility operates on similar scales. The mathematics are overwhelming. His report circulated through intelligence channels and disappeared into filing cabinets, marked with notes suggesting American statistics were exaggerated for propaganda purposes. Japanese officers refused to believe a single American factory could outproduce their entire nation. The concept violated everything they understood about industrial capacity, efficiency, and national capability. April 18, 1943. Bougainville Island, 9:34 hours. Lieutenant Doug Canning flew the No. 4 position in killer flight, one of 18 P-38 Lightning fighters launched from Guadalcanal on a mission so secret that pilots received their briefing only after engines were running. He was performing standard patrol sweep procedures when his flight leader's voice cracked through the radio. "Bogies! 11 o'clock! Low." Canning spotted them at 9:34 hours and 17 seconds. 2 Mitsubishi G-4M Betty bombers at 4,500 feet altitude, flying precise formation with 60 escorts. At 9:35 hours and 3 seconds, Captain Thomas Lanphier, Jr., began his attack dive. At 9:36 hours and 31 seconds, Lanphier's guns destroyed the lead bomber's right engine. The bomber, carrying Admiral Isoroku Yamamoto, began trailing smoke. At 9:36 hours and 54 seconds, the bomber's wings separated from the fuselage. Elapsed time from engagement to destruction, 91 seconds. Kill time, 91 seconds. The bomber carrying the architect of Pearl Harbor, the commander who had conquered Southeast Asia's naval approaches, the strategist who had terrorized the Pacific for 16 months, crashed into the jungle canopy at 9:37 hours and 11 seconds. Lieutenant Rex Barber engaged the second bomber at 9:35 hours and 48 seconds. His 6.50 caliber machine guns and 120 cannon concentrated fire on the bomber's cockpit and engines. At 9:36 hours and 43 seconds, the second bomber crashed into the ocean. Elapsed time from engagement to destruction, 55 seconds. Kill time, 55 seconds. The Zero escorts engaged aggressively. At 9:37 hours, 3 Zeros attacked Barber's P-38. At 9:38 hours and 12 seconds, Lieutenant Bisbee Holmes destroyed 1 Zero. Kill time, 34 seconds. At 9:38 hours and 51 seconds, Lieutenant Ray Hine shot down a second Zero. Kill time, 27 seconds. At 9:39 hours and 16 seconds, Hine destroyed a third Zero. Kill time, 19 seconds from his previous kill, 44 seconds total engagement time. Total engagement duration, 4 minutes 52 seconds. Enemy losses, 2 bombers, 3 Zero fighters. American losses, 0. Kill ratio, 5-0. The ammunition expended in this 292-second engagement exceeded the monthly allocation for the entire Japanese base at Rabaul's fighter squadron. American P-38s fired approximately 11,000 rounds of .50 caliber ammunition and 400 rounds of 20 cannon shells. Rabaul's monthly ammunition allocation: 8,200 rounds of 20 ammunition and 180,000 rounds of 7.7 ammunition for 45 fighters. The Americans expended 2% of a single base's monthly 20 allocation and 6% of .50 caliber equivalent in less than 5 minutes. Lieutenant Commander Yanagiya, flying escort that day, survived the engagement and returned to Rabaul in shock. They knew, he reported to Vice Admiral Yugaki. The Americans knew the Admiral's exact schedule, his exact route, his exact altitude. They were waiting at the precise intercept point. 8 fighters attacked immediately. No hesitation, no patrol pattern, direct intercept. They knew everything. The engagement summary that reached Tokyo stunned Imperial General Headquarters. Admiral Yamamoto dead, Chief of Staff Yugaki severely wounded, 2nd bomber destroyed, 3 escorts lost. The mission, a routine inspection tour to boost frontline morale, had become a precisely executed assassination. American fighters had intercepted a secret flight plan, flown 435 miles over open ocean to arrive at the exact interception point within 2 minutes of Yamamoto's arrival, destroyed both bombers within 91 seconds, and returned to base without losses. Intelligence dismissed the initial reports as exaggerated. Coincidence, one analyst concluded. The Americans conducted a routine patrol. They encountered the Admiral's flight by chance. Their success was luck, not planning. The alternative, that Americans had broken Japanese naval codes, decrypted the Admiral's itinerary, calculated interception mathematics, and executed the mission with precision, seemed impossible. American intelligence was not that sophisticated. American pilots were not that skilled. American operations were not that competent. Captain Watnabe compiled his report with hands that shook slightly. The Americans demonstrated tactical precision that suggests several capabilities we previously assessed as beyond their capacity, he wrote. First, signals intelligence penetration of our highest-level naval communications. Second, navigation accuracy sufficient to conduct a 435-mile overwater flight to arrive at a precise point within a 2-minute window. Third, fighter performance sufficient to engage and destroy veteran pilots in aircraft we assessed as superior. Fourth, combat efficiency suggesting systematic training in aerial gunnery that exceeds our previous estimates. This was not luck. This was planned, systematic execution. American production statistics supported Watnabe's concerns. In April 1943, American factories produced 7,421 military aircraft. Japanese production, 1,204 aircraft. A single American aircraft manufacturer, Lockheed, produced more fighters in April than Japan's entire industry. The Lockheed plant in Burbank, California, produced 1,340 aircraft in April 1943. Japan's combined production from Mitsubishi, Nakajima, Kawasaki, and 14 other manufacturers. 1,204 aircraft total, including trainers, transports, and reconnaissance types. They tried to dismiss it as statistical anomaly. Intelligence officers recalculated numbers, questioned sources, suggested American propaganda inflated production figures. They attempted to explain away the Yamamoto loss as unfortunate coincidence. Commander Doi personally flew the route Yamamoto's flight had taken, timing each leg, measuring distances, calculating interception mathematics. They would have needed perfect navigation, he concluded. Perfect timing, perfect intelligence, the probability of chance interception less than 1%. The Americans did not rely on chance. At Station Hypo in Pearl Harbor, cryptanalysts had broken JN-25, the Japanese naval code, in mid-1942. Lieutenant Commander Edwin Layton, Pacific Fleet Intelligence Officer, presented Yamamoto's complete itinerary to Admiral Chester Nimitz on April 14. Departure time, aircraft types, escort strength, route, destinations, arrival times. Nimitz authorized the interception mission. 18 P-38s launched from Henderson Field at Guadalcanal. Navigation calculations were precise. 435 miles at 200 miles per hour cruise speed, climbing to 10,000 feet, descent to wave-top level for radar avoidance, intercept position calculated to within 2 miles. They arrived at the intercept point at 9:34 hours. Yamamoto's flight appeared at 9:34 hours and 17 seconds. Recognition came slowly to Japanese intelligence. They tried conventional tactics first, increased escort strength. Result, American fighters ignored escorts, concentrated on bomber targets. They attempted altitude variations, flying at 18,000 feet. Result, American fighters climbed to intercept altitude. They tried radio silence. Result, Americans intercepted based on scheduled flights and predicted routes. 4 attempts to secure high-level inspection tour resulted in 3 canceled flights and 1 near interception that forced Vice Admiral Yugaki to abort his mission to Buin. Captain Watanabe presented his final assessment in May 1943. We are fighting an enemy that possesses 3 critical advantages we cannot overcome with current capabilities. First, signals intelligence penetration that compromises our operational security at every level. Second, industrial production that generates numerical superiority we cannot match. Third, systematic tactical development that transforms numerical superiority into combat effectiveness. The mathematics are unfavorable. Commander Doi studied patrol reports from Rabaul with increasing concern. American fighter sweeps increased from 12 per week in February to 47 per week in May. Each sweep involved 1624 aircraft. Japanese fighter strength at Rabaul, 45 operational fighters. American fighter strength in the Solomons, estimated 340 operational fighters. Each engagement produced kill ratios that eroded Japanese strength. At Rendova on May 7, Japanese pilots shot down 4 American fighters but lost 11 Zeros. At Vella Le Vella on May 14, they destroyed 6 American aircraft but lost 9 fighters. At Bougainville on May 21, they shot down 8 Americans but lost 14 Zeros. Lieutenant Commander Yanagia observed the pattern with veteran pilots' understanding. Every week the Americans send more fighters, he recorded. Every week we have fewer pilots. Not fewer aircraft, we receive replacements from Japan. Fewer pilots. The Americans lose pilots and they return next week with new men. When we lose pilots, they are gone. Their experience is gone. Their knowledge is gone. We cannot replace expertise with enthusiasm. Vice Admiral Yugaki, recovered from his injuries, finally acknowledged what Captain Watanabe had warned about for months. Admiral Yamamoto's death was not coincidence, he wrote in his diary on May 27. It was systematic. The Americans read our codes, planned their interception, executed their mission, and achieved their objective. We have been deceiving ourselves. Their industrial capacity is overwhelming their tactical deficiencies. Their ability to replace losses is overwhelming our ability to inflict them. June 16, 1943. Guadalcanal, 14:07 hours. 94 Japanese aircraft, 67 fighters, and 27 bombers launched from Rabaul to attack American shipping at Guadalcanal. The mission represented Japan's largest air offensive since November 1942, a maximum effort designed to destroy American supply vessels and demonstrate that Japanese naval aviation retained offensive capability. 120 American fighters intercepted them. The engagement lasted 23 minutes. At 14:07 hours, the first wave of Japanese aircraft entered radar detection range. At 14:09 hours, American fighters launched from Henderson Field, Fighter 1 and Fighter 2 airstrips. At 14:23 hours, combat began. At 14:46 hours, the last Japanese aircraft withdrew toward Rabaul. At 14:23 hours, 24 P-38 Lightnings engaged the Japanese fighter escort at 18,000 feet. At 14:26 hours, 11 Zeros were destroyed. Kill time per aircraft, approximately 16 seconds. At 14:27 hours, 32 F-4U Corsairs attacked the bomber formation at 14,000 feet. At 14:32 hours, 19 bombers had been destroyed. 0 American losses at this point in the engagement. At 14:33 hours, the remaining Japanese fighters, now reduced to 43 operational aircraft, attempted to protect the 8 surviving bombers. At 14:37 hours, 18 more Zeros were destroyed by a third wave of American fighters, 36 F-6F Hellcats from Navy carriers providing combat air patrol. At 14:41 hours, 5 more bombers were shot down. At 14:43 hours, the remaining 3 bombers jettisoned their payloads and fled. None reached any American vessels. Enemy aircraft destroyed, 24 bombers out of 27 launched, 29 fighters out of 67 launched. Total Japanese losses, 53 aircraft. American losses, 6 fighters, 3 F-4U Corsairs, 2 F-6F Hellcats, 1 P-38 Lightning. Kill ratio, 53-6, or approximately 9-1. The ammunition expended exceeded Japanese monthly allocation for 3 airfields. American fighters fired approximately 240,000 rounds of .50 caliber ammunition and 11,000 rounds of 20 cannon shells. Japanese monthly ammunition allocation for Rabaul, Buin, and Buka airfields combined: 24,600 rounds of 20 ammunition and 540,000 rounds of 7.7 ammunition for 156 aircraft. The Americans expended 45% of the 20 allocation and 44% of the machine gun equivalent in 23 minutes. The fuel consumed in this engagement exceeded Japanese weekly allocation for the entire Solomon Islands. American fighters flew an average of 1.7 hours during the engagement launch, climb to altitude, combat, pursuit, return. 120 fighters consuming an average of 220 gallons per flight, 26,400 gallons of aviation gasoline. Japanese weekly fuel allocation for all air operations in the Solomon Islands, 32,000 gallons. One engagement consumed 82% of a week's allocation. At 14:37 hours and 32 seconds, Vice Admiral Yugaki, flying as observer in a Zero fighter, watched American fighters destroy 3 Japanese aircraft in 16 seconds. The Americans did not dogfight. They executed slashing attacks, high-speed dives from superior altitude, concentrated gunfire, immediate climb back to attacking position. Japanese fighters, attempting to engage in turning combat where the Zero's maneuverability provided advantage, found themselves constantly defensive against aircraft that refused traditional dogfighting. "This wasn't combat," Yugaki wrote that night. "This was systematic annihilation. The Americans did not seek to outmaneuver us. They used altitude, speed, and firepower to destroy us. Our tactics developed against opponents who would engage in turning combat were useless against opponents who simply refused to fight that way. And when we damaged their aircraft, they landed, repaired, and returned. When they damaged ours, we crashed, burned, and died." At 14:44 hours and 18 seconds, Commander Doy's Zero took 6.50 caliber hits across the wing root. At 14:44 hours and 31 seconds, his wings separated from the fuselage. Elapsed time from engagement to death, 13 seconds. The Mocker, the senior officer who had dismissed American industrial capacity and pilot quality, died 900 miles from Tokyo without ever understanding that his confidence had been built on calculations that did not account for an enemy that revolutionized production, tactics, and training simultaneously. Lieutenant Commander Yanagia survived, his aircraft damaged but controllable, limping back to Rabaul on one engine with 47 bullet holes in the fuselage. He counted American fighters during the withdrawal. "There were always more," he reported. "We destroyed 6, but there were always more, formations of 8, then 12 more, then 16 more. We were fighting an enemy that could lose aircraft faster than we could shoot them down. The mathematics were impossible." American production validated Yanagia's observation. In June 1943, American factories produced 8,619 military aircraft. Japanese production, 1,232 aircraft. American production exceeded Japanese production by a factor of 7 to 1. More significantly, American fighter production in June 1943 reached 4,840 aircraft. Japanese fighter production, 584 aircraft. The United States produced more fighters in June than Japan produced total aircraft in June, July, and August combined. Watanabe compiled his final report from scattered patrol records and pilot debriefings. "We cannot win," he concluded in text that would have resulted in court-martial if discovered by authorities. "Every engagement reduces our pilot's strength. Every loss removes experience we cannot replace. The Americans lose pilots and they replace them within weeks. We lose pilots and their expertise is gone permanently. Our production cannot match their losses. Their production exceeds our maximum theoretical capacity by factors we cannot overcome. The Guadalcanal engagement cost us 53 aircraft. American production replaces 53 aircraft in 5.4 days. Our production requires 43 days to replace 53 aircraft. The mathematics are final. We cannot sustain operations against an enemy that replaces losses 8 times faster than we can." Inglewood, California, June 1943. North American Aviation's Inglewood plant produced P-51 Mustang fighters at rates that stunned even American logistics officers. The facility completed 26 fighters daily. Every 55 minutes, another Mustang rolled off the assembly line. Monthly production, 780 fighters. This single facility produced more fighters monthly than Japan's entire aircraft industry produced aircraft of all types. Americans discarded more aluminum daily from production errors than Japan allocated monthly for fighter construction. Waste aluminum from incorrect pressings, failed forming operations, and quality control rejections at Inglewood, 18 tons daily. Japanese monthly aluminum allocation for fighter production, 420 tons for 584 fighters. Inglewood's waste represented 4.3% of Japan's total allocation. What Americans threw away in 23 days equaled what Japan used in an entire month. The facility's cafeteria waste exceeded Japanese combat rations. Daily food waste, 1,840 pounds overcooked meat, wilted vegetables, stale bread, spoiled produce. Japanese infantry regiment daily rations, 1,620 pounds for 1,100 men. American workers at one factory threw away more food than fed an entire Japanese infantry regiment in sustained combat operations. Paint overspray from coating operations accumulated as hazardous waste, 340 gallons daily. Japanese allocated paint carefully, mixing precise quantities, applying thin coats, recycling excess. Inglewood's paint waste exceeded monthly allocation for 3 Japanese aircraft plants. The overspray, perfectly functional paint that missed the target surface contained enough coating to paint 280 fighters using Japanese application methods. Americans generated as waste in one day what would paint Japan's entire 3-day production run. Cutting tools discarded for not meeting specifications, 73 cutting heads daily. Each head had been used for 140 hours of machining below the 220-hour specification, but still functional. Japanese machinists used cutting tools until they fractured, typically 380 hours. Americans threw away tools that Japanese craftsmen would have used for another 240 hours. The discarded tools from one day's production represented what Japan allocated as annual supply for 4 manufacturing facilities. Electrical wire scrap from cutting operations, 840 pounds daily. Copper wire, perfectly conductive, thrown away because cut lengths didn't match specifications exactly. Japanese electricians salvaged every inch of wire, stripped insulation, melted and reformed copper, reused every fragment. Inglewood disposed of more copper wire daily than Japan imported weekly. The wire scrap from this single facility's daily operations could have rewired Japan's entire monthly fighter production. Machine tool lubricant disposal, 420 gallons weekly. Used once, filtered, tested, and discarded when contamination reached 3%. Japanese facilities used lubricants until contamination reached 40%, then reprocessed them for industrial uses. 1 week's lubricant disposal from Inglewood exceeded Japan's monthly import allocation for industrial oils. The single facility discarded more usable lubricant weekly than Japan allocated monthly to its 3 largest aircraft manufacturers. Engine test stand fuel consumption, 14,000 gallons monthly. Each P-51 engine ran on test stands for 2.5 hours before installation, consuming 62 gallons of fuel per engine. Test protocols required full power runs, climb power runs, and combat power runs thorough testing that guaranteed engine reliability, but consumed fuel that Japanese logistics officers allocated for combat operations. The test fuel consumed monthly at Inglewood exceeded the combat fuel allocation for an entire Japanese fighter group of 45 aircraft operating for 30 days. Watanabe obtained translated American production manuals through intelligence channels, reading specifications that seemed fictional. North American Aviation's Inglewood facility employs 42,000 workers operating in 3 shifts, one document stated. Production capacity, 780 fighters monthly. The facility consumes 2,100 tons of aluminum monthly, 340,000 rivets daily, 18,400 linear feet of electrical wire daily. Component fabrication occurs at 73 workstations. Final assembly requires 11 hours from initial frame positioning to completed aircraft. The numbers contradicted everything Japanese manufacturing understood. Japan's entire fighter production, all manufacturers, all facilities, all shifts employed 38,000 workers and produced 584 fighters monthly. A single American factory employed more workers and produced more fighters than Japan's entire industry. The mathematics suggested either American exaggeration or Japanese fundamental misunderstanding of industrial capacity. Intelligence officers questioned the statistics. These numbers are propaganda, one analyst concluded. No single facility could produce 780 fighters monthly. The aluminum alone would require, he paused, calculating, 2,100 tons monthly. Japan's total aluminum production is 1,800 tons monthly for all military and industrial needs. This American facility supposedly consumes more aluminum than our entire nation produces. The claim is obviously false, but the claim was accurate. American aluminum production in 1943 reached 920,000 tons annually. Japanese aluminum production, 21,600 tons annually. The United States produced 42 times more aluminum than Japan. American monthly aluminum production, 76,666 tons, exceeded Japan's annual production by a factor of 3.5. The Inglewood facility consumed 2.7% of American monthly aluminum production. If Japan allocated its entire monthly aluminum production to a single facility, that facility could produce at 86% of Inglewood's rate, if Japanese manufacturing efficiency matched American efficiency, which it did not. September 1943. Solomon Islands air operations. Japanese air strength continued eroding under systematic American pressure. In July, they lost 87 fighters in combat operations. In August, losses reached 94 fighters. In September, losses exceeded 100 fighters for the first time. American losses, 23 fighters in July, 31 in August, 28 in September. Kill ratios averaged 3-4-1 in American favor. The mathematics became crushing when compared to production rates. Japanese fighter production, 584 monthly. Combat losses, 94 monthly average from July through September. Operational accident losses, 37 monthly average. Training accident losses, 18 monthly average. Total losses, 149 monthly. Net production, negative 65 fighters monthly. Japan was losing fighters faster than factories produced them. American production absorbed losses without noticing. Fighter production, 4,840 monthly in June, 5,240 monthly in September. Combat losses, 27 monthly average. Operational accidents, 86 monthly. Training accidents, 142 monthly. Total losses, 255 monthly. Net production, 4,985 fighters monthly. The Americans lost more fighters to training accidents than Japanese pilots destroyed in combat, and they still added nearly 5,000 fighters monthly to operational strength. Watanabe's September intelligence summary stated the situation plainly. We are not losing this war in combat. We are losing it in factories. For every fighter we produce, America produces 9. For every pilot we train, America trains 8. For every barrel of aviation fuel we refine, America refines 42. The mathematics are final. We cannot sustain operations at current loss rates. American production replaces our maximum effort losses in 4.7 days. Our production requires 33 days to replace equivalent losses. Continuation of current operations guarantees numerical obliteration by mid-1944. Japanese pilot quality declined measurably. In January 1943, average Japanese fighter pilot flight hours before first combat mission, 650 hours. By September 1943, 280 hours. By December 1943, 120 hours. Training programs compressed to replace losses faster graduated pilots who lacked fundamental skills. Navigation errors increased. Combat formation discipline collapsed. Gunnery accuracy decreased. Pilots who in 1941 achieved 25% hit rates in combat were replaced by pilots achieving 4% hit rates. American pilot quality improved with systematic training. Flight hours before first combat mission increased from 220 hours in early 1942 to 340 hours by late 1943. Training programs expanded, standardized, and incorporated combat lessons learned. Gunnery training used full-scale mock-ups and realistic target drones. Navigation training included overwater flights. Tactical training emphasized energy fighting altitude and speed management rather than dogfighting. Pilots arrived in combat theaters with skills refined through systematic instruction. Lieutenant Commander Yamamoto noticed the change immediately. In 1942, when we engaged American formations, their discipline would collapse after the first pass, he recalled. By mid-1943, their formations remained intact through multiple engagements. Their pilots followed doctrine, maintained mutual support, executed coordinated attacks. They were not individually more skilled than our pilots, but their systematic approach generated combat effectiveness that exceeded individual skill. They had industrialized air combat standardized tactics, predictable doctrine, mutual support. We relied on individual excellence. They created systematic superiority. Willow Run, Ford's B-24 production facility. September 1943. Production reached 650 bombers monthly. The facility operated 24 hours daily, 3 shifts of workers producing bombers with mechanical precision. The assembly line moved continuously, 9 feet every 4 minutes. Every 63 minutes, a completed bomber fully equipped, armed, fueled, test-flown, rolled toward deployment. Component production occurred at rates that seemed fantastic. Engines, 2,600 monthly 4 per aircraft. Propellers, 10,400 monthly 16 blades per aircraft. Wing sections, 1,300 monthly 2 per aircraft. Tail assemblies, 650 monthly. Fuselages, 650 monthly. Each component arrived at final assembly with timing choreographed to minute precision. No storage, no inventory buildup. Components moved from manufacture to installation within hours. The aluminum consumption exceeded Japan's total metal production. Monthly aluminum usage at Willow Run, 8,400 tons. Japan's total aluminum production, 1,800 tons monthly. This single facility consumed 4.7 times more aluminum than Japan produced. The facility's aluminum waste, 1,260 tons monthly from scrap, production errors, and quality control rejections, exceeded Japan's total fighter production aluminum consumption of 840 tons monthly. Americans discarded 47 tons of rivets monthly from quality control rejections. Rivets that didn't meet exact specifications. Dimensions within 0.001 inches. Aluminum alloy composition within 0.3% tolerance. Head formation within 0.0005 inches were rejected and remelted. Japanese manufacturing accepted tolerances of 0.008 inches for rivet dimensions. Willow Run's rejected rivets, perfectly functional by Japanese standards, could have built 840 fighters monthly using Japanese construction methods. The cafeteria operation alone demonstrated American abundance. Daily food service, 24,000 meals across 3 shifts. Daily food waste, 2,800 pounds. Monthly cafeteria food waste, 84,000 pounds. Japanese military monthly food allocation for a full infantry division of 18,000 men, 79,200 pounds. Willow Run's cafeteria workers threw away more food monthly than fed an entire Japanese division. Paint consumption illustrated similar abundance. Monthly paint usage, 84,000 gallons for bomber coating. Paint waste from overspray and line cleaning, 12,600 gallons monthly. Japanese monthly paint allocation for entire aircraft industry, 8,400 gallons. Willow Run's paint waste exceeded Japan's total allocation by 50%. The facility discarded more usable paint than Japan used for all aircraft production. The electrical system assembly line used 28 miles of copper wire daily wiring for 41 bombers. Daily wire waste from cutting operations, 4.2 miles. Monthly wire waste, 126 miles of copper wire, perfectly conductive, thrown away because cut lengths didn't match specifications exactly. Japan's monthly copper wire imports for all military and industrial use, 94 miles equivalent. One facility's wire waste exceeded a nation's wire supply. Hydraulic fluid consumption, 42,000 gallons monthly. Hydraulic system testing required filling each bomber's system, pressure testing, draining, refilling with fresh fluid. The drained fluid, perfectly functional, meeting all specifications, was discarded. Monthly hydraulic fluid waste, 6,300 gallons. Japanese monthly allocation of equivalent fluids for all aircraft, 4,200 gallons. Waste exceeded allocation by 50%. Oxygen system testing consumed 840 bottles of compressed oxygen daily. Each bottle contained 244 cubic feet of oxygen at 1,800 psi. Testing required filling aircraft oxygen systems, pressure testing, venting, refilling. The vented oxygen, perfectly breathable, meeting all purity standards, was released to atmosphere. Daily oxygen waste, 204,960 cubic feet. Japanese monthly oxygen allocation for all military aviation, 3.6 million cubic feet for 1,200 aircraft. Willow Run's testing waste equaled 5.7% of Japan's monthly aviation oxygen allocation. November 1943. Rabaul Harbor. 97 American carrier aircraft attacked Rabaul in Operation Cherry Blossom. The raid destroyed 11 Japanese ships, damaged 16 others, and eliminated Rabaul as a major naval base. Japanese fighter defense launched 68 Zero fighters. The engagement lasted 38 minutes. American losses, 9 aircraft, 4 shot down, 5 ditched due to damage. Japanese losses, 52 fighters destroyed in air combat, 11 more destroyed on the ground during strafing runs. Watanabe compiled the engagement statistics with mechanical precision. American attacking force, 97 aircraft. Japanese defending force, 68 fighters plus anti-aircraft artillery from 45 installations. Result, 11 Japanese ships destroyed, 16 damaged, 63 fighters lost, Rabaul rendered unusable as major fleet anchorage. American losses, 9 aircraft, 14 pilots. Kill ratio, 7:1. Duration, 38 minutes. Ammunition expended. Estimated 480,000 rounds .50 caliber, 18,000 rounds 47 tons of bombs. This expenditure exceeded 3 months' allocation for Rabaul's defense forces. The psychological impact exceeded the material losses. Rabaul had been considered impregnable, defended by hundreds of anti-aircraft guns, protected by veteran fighter squadrons, located beyond the effective range of American land-based aircraft. The idea that carrier-based aircraft could penetrate defenses, destroy shipping, eliminate air cover, and withdraw with minimal losses shattered Japanese strategic assumptions. They did not need to invade, Watanabe noted. They simply destroyed our capacity to operate. The ships we lost took 9 months to build. They destroyed them in 38 minutes. The aircraft we lost took 6 weeks to build. They destroyed them in less than an hour. The pilots we lost took 18 months to train. Gone in 38 minutes. Meanwhile, their losses, 9 aircraft, 14 pilots, will be replaced within 11 days. The mathematics demonstrate inevitable conclusion. American production statistics supported his analysis. Aircraft carrier construction in 1943. 14 fleet carriers, 9 light carriers, 50 escort carriers. Japanese carrier construction in 1943, 3 fleet carriers, 2 light carriers. American numerical superiority in carrier aircraft, 14,480 operational aircraft. Japanese carrier aircraft strength, 2,840 operational aircraft. The Americans possessed 5 times more carrier aircraft than Japan, and they were producing replacements 18 times faster. Pilot training capacity showed similar disparity. American naval aviation training graduated 12,400 pilots in 1943. Japanese naval aviation graduated 2,820 pilots in 1943. The Americans trained more pilots in 3 months than Japan trained annually. American training programs lasted 18 months and included 340 flight hours before first combat mission. Japanese programs, compressed by necessity, lasted 9 months and included 120 flight hours. February 1944. Truck Lagoon. Operation Hailstone, the American carrier raid on Truk eliminated Japan's main forward naval base in the Central Pacific. 5 days of raids destroyed 250 aircraft, sank 50 ships including 3 cruisers and 4 destroyers, and killed 4,500 Japanese personnel. American losses: 25 aircraft out of 1,250 sorties, a loss rate of 2%. Japanese defenders launched every available fighter, 127 aircraft. American fighters destroyed 91 of them. Kill ratio: 3-6-1. Lieutenant Commander Yamamoto, now stationed at Truk, watched the destruction from an air raid shelter. The carriers appeared on February 17, he recorded. They launched continuous strikes for 5 days. We scrambled every fighter. We engaged every raid. And every day there were more American aircraft. We shot down 25. They launched 1,250 sorties. The mathematics were overwhelming. For every American aircraft we destroyed, they launched 50 more. We could not sustain those ratios. The ammunition expenditure during Truk demonstrated American abundance. Fighter aircraft fired approximately 4.2 million rounds of .50 caliber ammunition during 5 days of raids. Bomber aircraft dropped 748 tons of bombs. Torpedo bombers launched 208 torpedoes. The total ammunition and ordnance expended exceeded Japan's 3-month allocation for the entire combined fleet. And the Americans resupplied their carriers at sea, transferred ammunition from fleet oilers and supply ships, and continued operations without returning to port. Japanese defenders fired every anti-aircraft round available, approximately 47,000 rounds of 25, 18,000 rounds of 40, 3,400 rounds of 75. They achieved 14 hits on American aircraft out of 68,400 rounds, fired a hit rate of 0.02%. Then they ran out of ammunition. On February 19, American aircraft strafed installations without ground fire opposition. Japanese gunners had no ammunition left. The fuel consumption during Truk operations exceeded imagination. American task force consumed approximately 680,000 gallons of aviation gasoline during 5 days, launching, recovering, and operating 1,250 sorties. Japanese monthly aviation fuel allocation for all Central Pacific operations: 420,000 gallons. The Americans consumed 162% of Japan's monthly allocation in 5 days of operations at a single location, and they refueled at sea from fleet oilers carrying 24 million gallons. Watanabe's analysis of Truk concluded with stark assessment. We have lost the Central Pacific. Not because their tactics are superior, our pilots fought bravely. Not because their aircraft are overwhelmingly better, the Zero remains maneuverable. We lost because they possess resources we cannot match. They expended more ammunition in 5 days than we allocate in 3 months. They flew more sorties in 5 days than we fly in 2 months. They lost 25 aircraft and did not pause operations. We lost 127 aircraft and ceased operations. The mathematics are final. October 1944, Leyte Gulf. The Battle of Leyte Gulf destroyed Japanese naval air power permanently. Over 4 days of combat, American forces sank 4 Japanese aircraft carriers, 3 battleships, 10 cruisers, and 11 destroyers. Japanese aircraft losses exceeded 600. American losses: 200 aircraft, 3 light carriers damaged, no major combat vessels sunk. The carrier Zuikaku, last surviving carrier from the Pearl Harbor attack force, sank on October 25 with 843 crew members. Her aircraft, 18 fighters, 27 dive bombers, had launched that morning. 2 fighters returned. The mathematics of Leyte Gulf demonstrated industrial warfare's final form. Japan could not replace losses. America could not stop producing replacements. Lieutenant Commander Yamamoto, transferred to Philippines Defense Forces, survived Leyte Gulf and wrote his final combat assessment. We faced an enemy that could absorb losses that would cripple our forces and continue operations without pause. On October 24, American carrier aircraft attacked continuously from 8:30 hours to 18:30 hours, 10 consecutive hours of strikes. We estimated they launched 380 sorties that day. Our entire carrier force at Leyte 4 carriers possessed 116 aircraft total. They launched more strikes in 1 day from their carriers than we possessed in our entire force. When we destroyed their aircraft, more appeared. When we damaged their carriers, more carriers arrived. The abundance was crushing. American carrier force at Leyte Gulf, 17 fleet carriers, 18 escort carriers. Total aircraft, 1,280. Japanese carrier force, 4 carriers with 116 aircraft. The Americans deployed 11 times more aircraft from 9 times more carriers. When Japan committed its entire remaining carrier force to battle, America deployed half its Pacific Fleet carrier strength and still outnumbered Japanese forces 11-1. Production statistics from October 1944 showed the final disparity. American aircraft production, 9,113 aircraft. Japanese production, 1,583 aircraft. American pilot training, 5,400 graduates. Japanese training, 940 graduates. American aviation fuel production, 4.2 million barrels. Japanese production, 180,000 barrels. Every metric demonstrated American superiority by factors of 5 to 8 times. The aluminum consumption comparison crystallized the production disparity. American aluminum production in October 1944, 89,400 tons. Japanese production, 1,420 tons. The United States produced 63 times more aluminum than Japan. A single American facility, Alcoa's Tennessee plant, produced 12,400 tons monthly, exceeding Japan's entire national production by a factor of 8.7. The mathematics were devastating. December 1944, Tokyo. War Ministry Interrogation Facility. Captain Watanabe Yasuji submitted to interrogation after his persistent warnings and negative assessments came to official attention. The interrogator demanded to know why his reports consistently emphasized American production capacity rather than Japanese fighting spirit. "We were not defeated by better soldiers," Watanabe stated carefully. "We were defeated by better factories." American aircraft production in 1944 reached 96,318 aircraft. Our production, 24,800 aircraft. A single American company, Ford Motor Company, produced more military equipment than our entire industrial base. Their Willow Run facility produced 8,685 bombers in 1944. Our entire industry produced 5,100 bombers. One American factory exceeded our total national production by 166%. The interrogator dismissed these statistics as defeatist propaganda. Watanabe continued regardless. "Consider aluminum. In 1944, America produced 1,072,800 tons of aluminum. We produced 17,040 tons. They produced 63 times more aluminum. Their waste exceeded our production. Their scrap metal exceeded our imports. Their production errors exceeded our maximum output. We could not win. The mathematics were absolute." Lieutenant Commander Yanagiya, now reassigned to Homeland Defense, provided testimony that confirmed Watanabe's assessments. "I flew combat operations from December 1941 through October 1944. I personally witnessed the transformation. In 1941, we possessed superior aircraft, superior pilots, superior tactics. We achieved kill ratios of 5-1-8-1, sometimes 12-1. By 1944, we were losing engagements at 3-1 ratios in their favor. What changed? Their aircraft improved incrementally. Their pilots improved systematically. But their abundance, their capacity to lose aircraft, lose pilots, lose equipment, and return next week with more, that destroyed us." Additional testimony from combat veterans provided the human dimension behind the statistics. Commander Goro Furugori, shot down over Leyte Gulf and rescued by American destroyer. "We brought honor and determination to combat. They brought abundance and organization. When I attacked American carriers, anti-aircraft fire was so intense I could not see the ships through the explosions. They fired so much ammunition that the sky turned black with shell bursts. We could not survive that volume of fire. It wasn't tactics. It wasn't courage. It was industrial capacity that generated firepower we could not overcome." Lieutenant Yasuo Kuwahara, bomber pilot who survived 30 missions over Philippines. "Their excess capacity exceeded our maximum effort. We allocated bombs carefully, 1 bomber, 8 bombs, specific targets. They dropped bombs everywhere. They bombed every building, every road, every bridge, every airfield. When we saw smoke from burning facilities, we knew they had bombed there. When we didn't see smoke, we knew they would bomb there tomorrow. They had so many bombs that they never ran out. We carefully preserved our ammunition. They threw ammunition at every target." Statistical testimony from logistics officers. "They could lose 200 aircraft and replace them within 9 days. We could lose 200 aircraft and require 147 days for replacement. They trained pilots in 8 months and deployed them with 340 flight hours. We trained pilots in 6 months and deployed them with 120 flight hours. They produced aviation fuel at rates that exceeded our production by factors of 23 to 1. Single American refineries produced more aviation fuel monthly than our entire nation. We were not outfought. We were outproduced. Production comparisons stated by Japanese personnel emphasized the industrial disparity. American aircraft production 1944, 96,318 total aircraft. Japanese production, 24,800 aircraft. Ratio, 388:1. American fighter production 1944, 38,873 fighters. Japanese fighter production, 13,811 fighters. Ratio, 281:1. Single American facility production, Ford Willow Run produced 8,685 bombers. Entire Japanese industry bomber production, 5,100 bombers. Single facility exceeded national production by 166%. American aluminum production, 1,072,800 tons annually. Japanese production, 17,040 tons. Ratio, 63:1. American pilot training, 64,800 pilots trained in 1944. Japanese training, 11,280 pilots. Ratio, 5:75:1. The democratic formula, the P-38 Lightning, proved that democratic industrial systems could generate military capability that exceeded authoritarian command economies. Free workers at Lockheed's Burbank plant produced 9,923 P-38s during the war, working voluntarily for wages, under conditions that respected human dignity, with production efficiency that increased steadily from 1942 through 1945. Japanese aircraft production relied on forced labor, conquered populations, and coerced cooperation, generating 24,800 aircraft annually at maximum effort versus American production of 96,318 aircraft using voluntary labor. Democratic cooperation exceeded totalitarian command. Industrial abundance buried ideological superiority under mathematical certainty. The innovation that Japanese officers mocked in April 1943, American industrial production, destroyed their military capacity by October 1944. Free markets generated production capacity that command economies could not match. Workers who chose their employment produced more than workers who were compelled. Democratic societies that respected individual rights created military power that exceeded authoritarian systems that valued only state objectives. The mathematics were final. Abundance generated through freedom overwhelmed scarcity imposed through coercion. April 14, 1943. Vice Admiral Yamamoto had laughed at American production statistics and dismissed American pilot quality. October 25, 1944. His flagship Yamato retreated from Leyte Gulf, Japanese naval aviation destroyed, carriers sunk, pilots dead. His mockery became history's most expensive miscalculation, measured in 2.3 million Japanese military deaths, cities reduced to ash, and a nation occupied by the industrial power he had dismissed as weak. The lesson remains: dismissing democratic nations as weak because they prefer peace, or underestimating free people's productive capacity because their societies value individual rights over state power, invites catastrophic miscalculation. The mathematics are constant across generations. Systems that respect human freedom generate productive capacity that command economies cannot match. Nations that value peace possess reserves of strength that appear only when threatened, and military forces that measure capability only by immediate combat effectiveness while ignoring the industrial foundations of sustained warfare lose not battles, but wars destroyed by abundance they could neither imagine nor counter.